In this video, we will dive into solving simultaneous linear equations or systems of equations in two variables. Firstly, we want to define what simultaneous means. According to the dictionary, it means occurring, operating, or done at the same time. In our case, we will be solving two linear equations at the same time in order to find the root set or the solution set. From the word linear equation, we also mean that the equations will be in the form y is equal to mx plus b, where b is the slope or gradient of the line, and then b is the y-intercept, or where the line intercepts the y-axis. Now, the ordered pair xy will be the solution set of the two equations, or the points at which the two lines intersect. Another way to call simultaneous equations is system of equations. That simply means that there are two equations in two variables. For example, we have the system y is equal to 3x plus 1, and then y is equal to minus x plus 5. When the question is written this way, the brace used in the notation indicates that the equations form a system. Also, the solution to a system of equations or linear equations in two variables is the ordered pair of numbers xy that is a solution to each equation in the system. There are three main ways to solve systems of equations in two variables. First, we'll talk about the graphical method. Secondly, the substitution method. And then thirdly, the elimination method. With the graphical method, we use either the graphics calculator or a graph paper and manually draw the two lines of the system of equations, and then where they intersect will be the solution set. Now note that when we use the graph paper, it will be difficult to obtain an exact solution because the lines are drawn by hand. That means that the point of intersection or the solution set of the equations will be an approximate solution. As an example, we will graph manually the system of equations y is equal to 3x plus 1, y is equal to minus x plus 5. When we do so, we realize that the two lines will intersect at the point 1, 4, as shown the diagram. Therefore, the solution or truth set is 1, 4. In other words, we can use this notation inside the braces x, y, such that x is equal to 1 and then y is equal to 4. We can always check our solution by substituting the solution set into both equations. So when we do so, we see that both produce 4 is equal to 4. That makes the equations true. Another way is to use a graphics calculator. In this example, we will use the free and powerful tool called Desmos to graph the two equations. Y is equal to 3x plus 1 and y is equal to minus x plus 5. As shown on the left here, the red line represents this equation and the blue line represents this equation. Now, the calculator automatically graphs these two lines, and then at the point of intersection we see that the point is 1, 4, and that is the same solution set we derived when we drew it manually on the graph paper. Again, we can see that the y-intercept of the blue equation is 5 and the y-intercept of y is equal to 3x plus 1 is 1. I encourage all my students to make good use of this free and powerful tool whenever they have a graphics question. The second method used to solve system of equations in two variables is the substitution method. Now, in this method, if we know the value of one of the variables, we can substitute that variable into the other equation to identify the unknown variable. As an example, when we are asked to solve the system of equations 15x minus 5y is equal to 30 and y is equal to 2x plus 3 by substitution, we will substitute y is equal to 2x plus 3 into the first equation. So wherever we see y, we will plug in 2x plus 3 and then solve for x. When we do so, we obtain x is equal to 9. Afterwards, we will substitute x is equal to 9 into the second equation and then solve for y. That gives us y is equal to 21. Therefore, the solution set is 9, 21. We can always check our answers by plugging in x is equal to 9 and then y is equal to 21 in the two original equations. When we do so, we get 30 is equal to 30 for the first one and then 21 is equal to 21 for the second one, confirming that our solution set is correct. In the third method, the elimination method, the concept of opposites is used to eliminate one of the variables. So for example, in the question solved by elimination, the set 3x plus 4y is equal to 7 and 2x minus 4y is equal to 13, we will use the addition property of equality to combine both equations, and the resulting equation will be used to solve for x. Now, what we mean by the addition property of equality is that if the solution set is the same for both equations, then it means that adding the left-hand side of both equations will equal to adding the right-hand side. And that is what we see here. Because 4y and minus 4y are already opposites, we can conveniently add the left-hand side of both equations and equate it to the right-hand side of both equations. When we do so, we get 5x is equal to 20, then x is equal to 4. Afterwards, we'll substitute x is equal to 4 into the first equation and produce y is equal to minus 1.25 or minus 5 over 4. Therefore, the solution set is 4 minus 1.25. In other words, we can write xy such that x is equal to 4 and y is equal to minus 1.25. Checking our solution proves that our solution set is correct. In a different system of equations, we would have to multiply either one or both equations by a number in order to produce opposites, which will eliminate each other when added together. So in this second example, we will multiply equation 1 by 5, then multiply equation 2 by minus 2. The goal is to produce opposites, 10x and then minus 10x, which cancel or eliminate each other out when added together. So after doing so, we obtain 10x plus 15y is equal to 5, and then minus 10x minus 14y is equal to minus 6. So when we add both equations by means of the addition property of equality, we obtain y is equal to minus 1. Then we will substitute that value into one of the original equations, equation 1 in this example. Then we obtain x is equal to 2. Therefore, the solution set to the above equation is 2, 1, or xy such that x is equal to 2 and y is equal to minus 1. Checking our solutions by plugging in the solution sets, we get 1 is equal to 1, and 3 is equal to 3, proving that our solution set is correct. Now, when solving systems of linear equations, we come across two main groups of systems. The first is consistent systems, and this one is also broken down into two main types: a system of equations where there's only one unique solution, and then one in which there are infinitely many solutions. Now, how is that possible? For the first one, because there are two different lines, the solution set is the point of intersection. Therefore, only one solution is possible. But in the second instance, the lines are the same, or we can say that one is a multiple of the other. You can see clearly that x plus y is equal to 3 has been multiplied by 3 to obtain 3x plus 3y is equal to 9. That means that when both lines are drawn, they will be on the same line. Now, for inconsistent systems, because the lines or linear equations do not intersect, therefore we don't have any solution whatsoever. In that case, the lines are parallel. Consistent systems can further be subdivided into two main types: independent systems and dependent systems. Simply, independent systems of equations are equations which have one solution, then dependent systems are systems of equations which have infinitely many solutions. With these groups of systems of equations in mind, we will be able to now solve for various types of simultaneous linear equation problems.